For this lesson on arithmetic sequences as functions, I'm going to go over the lesson and make sure you get the notes, but most of the practice we'll do together in class. The example shown is an arithmetic sequence. You can see that it's a sequence of numbers and there is a pattern to them, but what makes it arithmetic? Well, if there's a common difference, the function is linear. And if it's linear, then we can say the sequence of y values is arithmetic. But y values, where are the x's? The definition of an arithmetic sequence, you can see it highlighted in yellow, is a function whose domain or input is the set of counting numbers, and the range or output is the elements of the sequence. Here's what I mean. 35 is the first term in the sequence. 32 is the second term in the sequence. 29 is the third. 26 is the fourth. 23 is the fifth, and so on. The counting numbers are the x values of the sequence. So we have a function whose x values are counting numbers, and those are term numbers. So the second term is 32. The y values are the actual elements of the sequence itself. So if the sequence is linear, then the sequence of y values is called an arithmetic sequence. This works backwards too. If you're told that a sequence is arithmetic, then the function is linear. Let's take a look more closely at these. In this first example, to discover whether these sequences are arithmetic, you want to check for a common difference. So like we've done, you subtract beginning at the end. 22 minus 18 is 4. 18 minus 14 is 4. 14 minus 10, and 10 minus 6. Our common difference, we'll call it D, is 4. And that means, since a common difference exists, that this is linear, which tells us that the sequence is an arithmetic sequence. Try the same with each of the others. Pause the video, and when you come back, you can check your work. How did you do? Did number 2 trick you? It started out having what looked like a common difference, but by the third and fourth subtraction, you got a different answer. The common difference has to be in common for everything. So no common difference here means it's not arithmetic. For number 3, there was a common difference, D, equal to -8, which tells us it's linear, therefore it is arithmetic. Number 4, you saw quickly, did not have a common difference, therefore not arithmetic. Like so much of algebra, a lot of what you learn is in the notation. So let's make sure that you understand what a sequence looks like, how we name the terms, and what each term or element of the sequence is referred to as. A sub 1 tells us, denotes, that it's the first term of the sequence. So in this case, A sub 1, notice 1 is a subscript, not superscript, that's an exponent. Subscript is written lower. A sub 1 means the first term. And if we look at this sequence, the first term is 3. So therefore we write A sub 1 equals 3. We're reading this as A sub, in this case, the next one, 2. This means the second term. And if it was A sub 34, I'd be talking about the 34th term. A is not a variable here. It is just kind of a placeholder to talk about whatever term it is we need. The general way of expressing that, any term where we don't maybe know the term number, or we just want to generalize what we're talking about, would be a sub n. That means the nth term. We could be talking about any number. If we were talking about a specific one, we'd replace the n with that number. N represents a term number. A sub 7, what would that be in the sequence above? And how could you figure it out? Well, we see a pretty straightforward pattern here, right? 3, 5, 7, 9. The fifth term, would be 11. And the sixth term would be 13. And the seventh term would be 15, just by following this pattern of odd numbers. So the way that we would express that is that a sub 7 is equal to 15. You read this as the seventh term is 15. Okay, let's get specific with your notes here. So terms can be named using a sub n. N is the term number. That's important. You need to make sure that you know that if you know the term number, you replace the n with that number. But there's something else that's often used when we're talking about a sequence. Sometimes we say or see something like a sub n plus 1 or a sub n minus 1. Don't let this scare you. This just means the term after a sub n. Think about it. A sub n plus 1. If n is 3, the third term, then n plus 1 would be 4, wouldn't it? And isn't that the term after a sub 3? So all this is saying is the next term. In the same respect, a sub n minus 1, that's just the term before a sub n. Think about it again. If you're given a sub 3, a sub n minus 1 is 3 minus 1. That's a sub 2. And isn't that the term before a sub 3? So you're just memorizing that the n plus 1 in the subscript is the one after a sub n, and the one with n minus 1 in the subscript is the term before a sub n. But if you think about it, it makes sense. So in order, a sub n minus 1 comes first, then a sub n, and then a sub n plus 1. And the next one would be a sub n plus 2, a sub n plus 3, a sub n plus 4. We rarely use those, but these you will see. And I want you to read them with the words, the next term or the term before. Okay, here's the formulas for arithmetic sequences. They look a little scary, not gonna lie, but I promise you we're gonna go through lots of examples in class. There's two formulas, the explicit formula and the recursive formula. We use the explicit formula to find any term. So no matter what, as long as we have certain information, we could find the 75th term if we want to, or the 107th term if we wanted to. And what we need to do that is we have to know the first term, a sub 1, and we have to know the common difference, d. With those two pieces of information, you can find any term. I want you to put the formula in your notes, but it's important to also put the words in there as well as when we use this formula to find any term. Now the recursive formula has two parts. The first part is just saying what the first term is equal to. The second part basically reads, to find a term, take the term before it, right, a sub n minus 1, and add the common difference. You guys, this is just telling you what the pattern is. That's it. It's saying to get to the next one, add this. And the one after that, add this again and again. That's what a common difference does. So it just gives you the pattern. To use the recursive formula, you're really only going to use it to find a term near one you already know. So if you know the 7th term and you need the 8th term, you're just going to add the pattern, the common difference, and get the next one. A recursive formula is really simple and useful for that reason. Put these in your notes and we'll go over some examples. Pause the video to get it written down. Okay, so to complete the recursive formula for a sequence that you're given, this is one we've already looked at. You need two things, a sub 1 and d. So a sub 1 in this case, the first term, right, is 6. And d, we already figured it out, is 4. So to write the recursive formula, you're just plugging in d, right? You copy this part the same, so a sub n equals a sub n minus 1 plus 4, and you tell what a sub 1, the first term, is equal to. It's 6, so you just repeat that information. We're basically giving the pattern and the first term and saying, work it out from there. We'll try the second one together in class, but why don't you give it a shot now and see how you do. This time we're going to look at the same sequence. We have the same information. The first term, a sub 1, is 6. D, the common difference, is 4. But now we're going to plug into the explicit formula. And you'll see, we'll do examples in class about why we would use one formula over the other one. So you just plug in the formula, a sub 1 comes first. We know that, it's 6, plus d, the common difference, and then you have these parentheses, n minus 1. Remember, we don't know n yet. They're not asking us for a certain term. We're just writing the general formula. So n sort of acts like our x. We're going to show you in class how to do these, and we will do this other example. But again, why don't you give it a shot now, and we'll do some more and check that during class.